Hello, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at sum and difference of cubes as a pattern for factoring. So I want to start with sum of cubes. It's basically what it says. It's a sum of cubes. So you're going to be looking at an expression that has two terms. Each term is a cube, and they are joined by addition. So the pattern for sum of cubes looks like this. If you find that you've got a sum of cubes, you'll know it's factorable. And the factors are a plus b, a squared minus ab plus b squared. I'm going to show you why those factors are correct by expanding this. We'll just do a bit of a review of multiplying polynomials. And you'll see that this actually does equal this. And then we'll look at some examples. If I were just to multiply this out, this would be my result. So I'm going to take this term in the binomial and multiply to each term in the trinomial. So I'll have a cubed. A times negative ab will be minus a squared b. A times b squared would be plus ab squared. Plus a squared b minus b times ab will be ab squared plus b times b squared is b cubed. Now you notice that we have a negative a squared b that is a like term with positive a squared b, and when I add those I get a 0. I have ab squared and negative ab squared, so when I add those two terms my result will be 0. So all that I'm going to be left with is a cubed plus b cubed. So now that I've proven that to you, now you can be comfortable in using this pattern. I want to point out that this factor itself cannot be factored. So unless you have maybe a common monomial factor in there by chance, but hopefully you've taken that out before you started, don't spend any time trying to factor that. Can't do it. All right, I'm going to just have the pattern in front of me while I'm doing these examples just to remind you what the pattern is. Our first example, you may find it easier when you're asked to do these factoring questions to express them as perfect cubes before you start. So in this case, I know that 8 is 2 cubed, so I can express this term as 2t cubed. And you can think of this as v cubed. The brackets aren't necessary, but it just might help you see what I'm doing in the example. Now it fits this pattern. I have something cubed plus something cubed. I'm going to plug into my factors, or my pattern of factoring. So the factors are a, which is 2t in this case, plus b, which is a v, times a squared, so that will be 2t squared. I'll keep those brackets, so inner brackets are going to be rounded, so I'll use the square brackets outside of that, minus ab, so minus 2t times v, plus v squared. Now a lot of these brackets aren't necessary, I just don't want to lose anybody, so I'm going to show you every single step. I can clean this up, make it look nice, get rid of some of those brackets. So 2t squared will be 2t the whole thing squared will be 4t squared minus 2tv plus v squared. And I've factored it. Don't spend any time trying to factor this because it's not factorable. All right, let's take a look at another example. We have x to the 6 plus 64. And we could think of that in terms of sum of cubes by expressing x to the 6th as x squared cubed. Going back to our laws of exponents, remember that x squared cubed, we multiply our exponents. So x to the 6th can be rethought of as x squared, the whole thing cubed. And we know that 64 is 4 cubed. So now that you've got it specifically written as a sum of cubes, now we can plug into our pattern. So this factors to x squared plus 4 times a squared, so x squared squared minus a times b, so 4x squared, plus b squared, 4 squared. Sorry, I should have put a square bracket here again. Again, I want to clean this up. So x squared squared, we multiply. That would be x to the 4th minus 4x squared plus 4 squared is 16. So this would be the factored expression, for this question, for this example. Sometimes you'll encounter expressions where it doesn't immediately look like a sum of cubes, which is the case here. But remember, the first thing we usually do when we are asked to factor is we see if there's a common factor to each term, and if there is, we factor it out. So we can take a look here. We have a common factor of 2, and we have a common factor of m. So if we factor 2m out, we're going to be left with m cubed plus 8n cubed. Now what we're left with is a sum of cubes, which means we can factor. And I'm going to do this without as many brackets, just to show you you can go straight to the pattern without that intermediate step that I have been showing. If you want to do that intermediate step, by all means do it. Whatever works for you to keep it straight. So my A is like the m, and my B is like 2n. So I'm going to have m plus 2n, and I'm going to have m squared minus a times b. In this case, it would be 2n times m, so 2mn, plus b squared. 2n squared will give you 4n squared. And now we've completely factored. But it took that first recognition of taking that common factor out before you ended up with an expression that you could then further factor. So remember to do that first. It will make it easier, and it will also often give you something that's factorable that wasn't before you took that out. Okay, let's take a look at difference of cubes. When we look at difference of cubes, the pattern is very, very similar to sum of cubes. The difference really is in the signs. So if you take a look, that's sum, which means you add. Difference means you subtract. And then when you look at the actual factors, they're very similar. So instead of a plus b, we have a minus b. So we had a change of sign right there. Then instead of this second factor, a squared minus ab plus b squared, we have a squared plus ab plus b squared. So what changed was this sign and this sign, and that's it. Otherwise, the pattern is very, very, very similar. So let's take a look at some examples. This question doesn't look like we can factor in terms of difference of cubes. However, if we take a look, we know that we can factor out something that's common to both terms, and that would be a 6, as well as the highest power of t that we can factor out, which happens to be the 3. That's the highest one that will go into both of those evenly. And then what I'm left with, when I factor that out, 6t to the 6 divided by 6t cubed will leave me with t cubed minus this divided by this is a 1. All right, now that we've factored 6t cubed out, we're left with an expression that is factorable. This is a cube, this is a cube, there's a difference, so we use our difference of cube pattern. And I've written it up at the top so that we can just follow along. So we leave the 6t cubed alone, and the pattern says the factors will be equal to a minus b, so that would be t minus 1 times t squared plus 1 times t plus 1 squared. So that would be my result. It's totally factored. Again, just like in the other case with sum of cubes, this is an expression that can't be factored. So don't waste any time trying to factor this. So I'm not going to worry about doing any more with this. This cannot be factored. Oftentimes when students see a question like this, they want to give up. they get a little intimidated and think, oh, that's not what I'm used to. But it really is the same process. It's just we've put an expression in instead of a letter. And I want you to still follow the pattern exactly the same way. It's just going to take a few more brackets and then some simplification, but we're going to plug into this pattern exactly how we did before. But instead of an a single variable, we're going to have the expression x plus y. And 64 is 4 cubed, so at the beginning, if you want to change that, that might or make it easier. So let's plug into our pattern. And I'm going to keep all of the brackets, even though some of them aren't necessary, just so that I don't lose you, and then we can simplify and get rid of the brackets afterwards. So to start off with, a, which is x plus y, minus b, b is a 4, times a squared, so a is x plus y, plus a times b. I'll just put the b first, I'll put the 4 first. So 4 plus x plus y, plus b squared, which would be 4 squared. Now we're just going to get rid of these brackets so that we have a nice simplified expression. These brackets are unnecessary, so this is just going to be x plus y minus 4. The inner brackets are unnecessary. The outside ones certainly are still necessary. So we could leave it, or the other option is we're going to expand it. So when I square this, x plus y squared, that's like x plus y times x plus y. Because remember, you can't just square each term. That doesn't work. We're squaring the whole expression, which means we're multiplying every term in the one binomial to every term in the other binomial. So when I expand that, I will get x squared plus xy is plus 2xy plus y squared plus 4x plus 4y plus 16. Now when you see this result, I prefer this over this for a number of different reasons. One is this looks awkward because of all the brackets. It also is what's called partially factored, so it's an expression that contains some terms are factored but not the whole thing. So I prefer to get rid of all those brackets and just express it. However, if your powers became very high, then you wouldn't want to expand, because you would end up with something this long and you wouldn't have room for it. So there's no hard and fast rule. Know how to deal with it if you are expected to expand, or find out if you can leave it in that form. I want to make one observation or one note. In the previous video and this video, all three patterns that we looked at, which were difference of squares, sum of cubes, difference of cubes, all of those expressions had two terms. And when the terms are cubed, we had a pattern for both a sum and a difference. If they were squared, we only had a pattern for difference. So anytime you have two terms, you should, after factoring out any common factor, is look to see if it fits any of these three patterns. They're really the only patterns that you're going to be able to use when you have two terms in an expression that you're asked to factor. This concludes our video on factoring sum and difference of cubes. In the next video, we're going to take a look at factoring by grouping. All right, take care and see you then.